Good afternoon and welcome to ATG webinar, Grading for Architects. My name is Matt Linn and I will be your virtual host for today. This webinar is intended for architects or any design professional who would like to develop the site plan in Revit. As we all know, Civil 3D is the preferred platform for site development. Hence, most civil engineers lean towards this format. If you're like me and many other architects out there, you've probably linked in a CAD drawing produced by the civil engineer in your Revit file and basically left those site plan as two-dimensional CAD lines for the duration of the project. There's nothing wrong with this approach and it's probably sufficient for most projects out there. However, what if you're designing a project on a sloped site and the grading plays an important role in the overall design? In this case, we would encourage using Revit's innate tools to develop the site in 3 dimensions. So in this webinar, we will cover how to learn to create topography, how to create existing and proposed contours, revise grading as required for the proposed structure, calculate cut and fill with a Revit schedule, determine a finished floor elevation that produces a net zero cut and fill, and then finally use subregions for paving to follow the slope of the land. Okay, so first, let's establish a simple layout with a property line and a building footprint. For this example, I'll just go ahead and use detail lines for the building footprint. Obviously, if you've already drawn your plan in Revit, you would use your modeled elements in lieu of detail lines. All right, so I am in level 1. I'm going to switch over to the site plan, and then I'm going to jump to my massing and site tab. Now right here, I'm going into the property line dialog, and you can see there's basically 2 ways to create a property line. You can create it by entering distance and bearings. So if you have an actual survey and has this value, it's probably worth go ahead and inputting those values. Otherwise, you can create by sketching, which is what I'm going to do here. It's faster, it's more intuitive. And I'll just make a simple 300-foot square property. So 90,000 square feet or roughly 2 acres. All right, now I'm just going to center this up by moving it to the endpoint to the midpoint. Same thing here. And then again, as mentioned, I'm just going to use detail lines to roughly draw out the plan of the building. Okay, I'm going to go 100 feet this way, and I'll come down 50 feet. So we have a basic 5,000 square foot floor plate. So this could be like a large 1-story house. Okay, I'm going to grab the things that I don't want to see and go ahead and hide their category via the VH. Okay, so now that we have that, let's create the topography, which defines the surface of the site in a 3-dimensional format. Note, if you have a 3-dimensional site plan or survey in DWG form or other vector-based applications, you can quickly create the topography by referencing that file. A lot of times, civil engineers will have this information available in 3D. So in this example, we're just going to utilize a simplified square that varies in elevation from 15, we'll go from 0 to 15 feet. Okay, so I'm going to go back to my massing and site tab. And I'm going to use the Topo Surface command, which is right here. So now when you go to the Topo Surface command, you can see place joint is the default place it'll go to, which is what we want to do here. And after you select place joint, you tell it what elevation you want it to go to. Okay, so I'm going to say we want 0. So I'm going to place points in all 4 corners. And so automatically it's created a plane, a square plane at elevation 0, 0. So if we go look at it in elevation, we can see it aligns with level 1. And it is a flat plane. There's no thickness to it. Okay, now I'm going to go back to Edit Surface, which brings us back to sketch mode. And I'm going to use this place joint again. And I'm just going to rough in some contours for this example. So it's the same method. You use place point and you just give it the elevation you want. Okay, so I'm going to just do intervals of 1 foot. Okay, so these are all the points I'm placing now are 2 feet. I'm going to bump it up to 3 feet and just keep going until I get up to 15 feet. So you can see as I'm doing this, it's not only creating the contours that I'm placing by just connecting the dots, it's also interpolating all of the other contours of the site as you go. Okay, so as you recall, I placed the 4 corners at an elevation of 0, 0. So that's why it's automatically creating all these contours to the left of what I'm doing. You know, everything to the right would make sense because I've already drawn those contours and I'm just going up by 1 foot with each time, now 7 feet. But on the left side of the contours, it's also automatically drafting them because it's going back down to the 0, 0 perimeter where we started. So in this example here, this topography will be the existing site before any construction begins. Okay, so that's why I'm kind of ignoring the house footprint for now. I'm just going to go right through. Again, this is representing the existing site before any construction. Okay, I'm just going to keep going. We're at elevation 10 now. I'm still just picking points. Up to elevation 11. Now you can see in the bottom left-hand corner, it's got a steep run of contours, which makes sense because when I placed that corner point, it was at elevation 0. Same type of thing is happening at both the northeast and northwest corners as well. We're creating a really steep slope at those corners, which is fine. We'll come back and address that in a bit. For now, I'm just going to keep drafting this 13-foot contour line. Okay, so we're up to 15 feet. All right, I am going to go ahead and finish this by hitting the green check mark. And let's take a look at this in 3D. So we have the single plane, and you can see it started to take on the slope of all the contours that we've input. And at the corners, you can see here's where I was talking. Those were input at elevation 0, 0. So it's automatically calculating the contours to get back down to that 0, 0. Okay, it's an easy fix. I'm just going to go back into Edit Surface. So if I look at the point here, it's at 9 feet. This one is at 10 feet. So I'm just going to split the difference at this corner, and we'll call it 9'6". And to clean that up. Same thing over here. That's at 12 feet and 13 feet. Again, we'll just split the difference at 12 feet, 6 inches. I'm going to grab that point and just simply delete it. So you can do that. Any point you see that's just, it's not calculating properly, you can simply delete points and it'll still interpolate the balance of the contours for you. Okay, so now I'm back out of sketch mode by hitting the green check mark. And now this looks a lot better. You can see it gradually goes from the low point at the southeast corner up to the high point of 15 feet at the northwest corner. Okay, so now what I'm going to do, I'm going to hit this section box because right now what we have is a single plane. It does not have a depth at all. If you want to provide some depth to your topography, you have to have a section box and it has to cut through it. And you can see I'm just barely going to cut over it. So when I zoom in, you can see it gives that little earth hatch down below as though it's a solid object. Only on that one side because that's the only side that actually cut the topography via the section box. So using that same principle, I'm just going to grab this section box and just barely come over the edge on each side. Like so. So now when I look at it in 3D, it looks like a solid object. And when you twist around it or rotate around it, you can start to see that thickness of that grade getting thicker and thicker as you go up. All right, I'm going to pull it down just a hair more so I can get a little bit more thickness at the low point. And then you can hide the section box. Even though it's hidden in the view, it's still there, just like any other Revit element. Okay, so now you can see we've got a solid object representing the contours as we have placed them. Okay, so now that we have the site modeled, we will focus on creating a building pad for the design. But before we do that, we must first utilize Revit phases to distinguish the site before construction versus the final design. So as I mentioned, that first one you drew, the topography we just completed, is representing the existing site prior to any construction. Okay, so let's address that by grabbing the topography itself and giving it the phase of existing. Okay, now when I did that, you can see it did in fact give it, or adjust the line weights, I should say. It's more of a half tone, just like any other Revit element that is controlled in the phase overrides or phase filters. Okay, now I'm going to use this graded region. Okay, so a graded region is the tool you use when you're going from existing to revised grades. And you have two different options here. You can create a new topo surface exactly like the existing one, which is basically just copies the entire topography element. Both internal and perimeter points are copied. Or you can create a new topo surface based on the perimeter points only, and it smooths out the interior. Now, my preference is the top one because you do have more control, but both have their place and both might be useful to you. For this example, I'm going to use this top one, which creates a copy of the entire topography. Okay, so you can see it automatically just created a new one. And if I select it, you can see it went ahead and put it on the new construction phase because it knows anything I do to that is considered new construction. If I tab select, it grabs the existing one. So there are two on top of each other right now. All right, so now let's go ahead and create a building pad using the building pad command, which takes us into sketch mode. So now I can simply trace the building pad. Again, this is new construction because it's a new pad. Okay, and I'm going to override graphics for the contours. Actually, I'm going to come back out of that. We'll do that later. Okay, so you can see we've got two in here, and the existing one has shown dashed where we've actually cut it out. Okay, and over here, phase filter, we currently have show all. So to make this a little bit more user-friendly, I'm going to show the complete, which, as you know, would hide the existing one, and now we're just left with the new contour or topo surface and the building pad. Now, when I laid it down, I give it a value of 0, 0. So just like that, I said, what does 10 feet look like? And it pops it up like so. And you can see what that pad will look like. And you can see over here at the northwest corner, it will, in fact, cut into the grade some. And at the southeast corner, it's high. And you can see it goes ahead and builds it up straight up from the perimeter of your pad. Okay, so it's pretty much like a void extrusion straight through your topography. Okay, so now that we have a building pad in place, we will start to address the grading around the building that responds to the flat slab on the sloped grade. Okay, so we're still in the show complete phase filter. This one is show all. I'm going to adjust this to the show complete as well, because it's easier to see what you're doing moving forward. Okay, so again, we placed this pad, we put it up at 10 feet, right? So now let's modify these grades that makes more sense so we don't have a really tall wall at the northeast and we don't have water coming into the building at the northwest. Okay, so as mentioned previously, you can grab points and you can delete them, you can move them, you can adjust them, you can do anything you want with the points, and all of the other contours will automatically be adjusted accordingly. Okay, so the first thing I'm going to do, I'm just going to do a sweeping view over my footprint, and I'm just going to delete them. And you can see it automatically, adjusted those contours for me. And now I'm going to go back and I'm going to place points around the perimeter of my footprint. And if you remember, the pad was at 10 feet. So let's say we want the grade to be 6 inches below finished floor all the way around the house. Okay, so no problem. I'm just going to place points at 9 feet 6 inches. So I'm going to place a point here, 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 and here. Doing something funny in the middle, so I'm going to add some at the midpoint as well. And just like that, it has adjusted all the contours to exactly 6 inches below my finished floor elevation. Okay, after I do that, I always come and take a look at 3D just to verify. It's always nice to have a visual verification. Okay, so if you can spin around, you see the finished floor elevation is exactly 6 inches above all of the surrounding grade. It's that simple. Okay, so I'm going to come back here and I'm going to go back to show all, which would show the existing one as well. And you can see, actually now I'm going to come back and override graphics and view by category, and I'm going to push that to 100% transparency. So you can see through and you'll be able to see the contour lines from both. And this will really help in our grading graphics, because now you can see anything that was modified in the existing is shown as dashed, and the new stuff is shown as solid. So you can easily see where you have modified the grades. Now the building pad is covering some of it up. So I'm going to temporarily hide that pad. And you can see just like that, we have a basic grading plan in place. And it will modify automatically as you continue to modify your design. Okay, so most people would probably agree it is best to equalize the cut and fill on a property so the contractor is neither hauling loads of soil off the site, nor hauling loads of dirt to the site. So the best way to do this, to verify, is achieved by creating a Revit schedule and to evaluate the impact of your site design. Okay, so let's do that. I'm going to come up to the View tab, and I'm going to create a schedule. And what we want to schedule is the topography. Okay, I'll just accept the default name. And this is important. You want to make sure you're doing the new construction, okay? Because that's the one that's showing the deviation from the existing site. Okay, so new construction phase, say okay. Come and grab your fields. I'm going to grab phase created. I'm going to do phase demolished as well. Now you can see there is a cut field, and there is also a fill field. It's hard to say, a fill field. And there's also a cut and fill field, which is really what I want, because all I care is about the net difference, right? Okay, so just like that, we have our schedule. It shows the phase created, phase demolished, and it shows the net cut fill. Now, both of these are positive numbers, which is indicated. The current design shows that we have some fill. They're going to have to bring some dirt to the site. You'll also notice there are two elements, and you'd probably expect there to be one, seeing as we're only doing new construction. But the reason there are two is whenever you put a building pad in, it creates a new topography element that adjusts exactly to the footprint of that floor plate. Okay, so that's why we have two elements. One is underneath the building pad and one is outside the building pad. All right, now that we have that, I'm going to come in and make some adjustments to the schedule here. All right, so I'm going to come over to sorting and grouping. And I would like to get these rows into one and have the math work itself out. So I'm going to say, I want to see totals only. I don't want to itemize every instance because I just want to see one row. I don't need to see both rows. And it needs to be a calculated value so we can add or subtract those numbers together. Okay, and just like that, we can see. So our current design, we are bringing 7,782 cubic feet of dirt to the site. Okay, so now we know how to create a schedule to measure the amount of cut and fill on site. Obviously, if you have a positive number, then your current design would require dirt to be hauled off the site. If you're trying to get back down to zero. And if your calculation indicates a negative number, then your design will require soil to be brought to the property. So let's use this information to revise the contours and or the finished floor elevation as required to come as close as we can to that net zero. Okay, so here we are again. Now, if you recall, we placed the building pad at 10 feet, okay? Now, since we have a positive number, we need to push that down, right? So let's take a look at 9 feet. So I just grabbed it, I changed the value to 9 feet, and it pushed that down. Okay. So if we come and take a look, our pad is now 6 inches below the grade. Not very good, right? We want the grade to be 6 inches below the finished floor elevation. Okay, so not a problem. I'm going to leave that at 9 feet. I'm going to come back to the site. I'm going to grab these points, and I'm just simply going to give them a different value of 8 feet 6 inches. And you can see just like that, it has modified all of the grade 6 inches below the finished floor plate. I can spin around, and you can see I always do the visual verification that it is precisely 6 inches below the finished floor elevation. So continuing on. Okay, so now we have our floor plate again, which is at 9 feet. So let's push it down to, bring it up to 9 feet 4 inches. And when to do that, I'm just simply going to come back, grab all of these points, and adjust the points as well. So now bringing it, I brought the floor plate up 4 inches. I'll bring this up to 8 feet 10 inches. Again, always do the visual verification, and I can see the grade is exactly 6 inches below the floor plate all the way around. And you can see as I do that, it automatically calculates or interpolates all the other contours as well. Okay, we're getting closer to zero. We're at 1,800 and change. So I think we can get a little bit closer. I'm going to take my floor plate and push it down. Let's try 9 feet 2 inches now. Okay, same thing. Come back, just simply select the points. So this needs to go down 2 inches, which will be 8 feet 8 inches. And we will finish that. Okay, and just like that, you can see we now have the floor plate where we want it. We have the grade exactly 6 inches below. And we're at 356 cubic feet. Okay, for this example, I'd say that's close enough. But you can keep going. If you can be as precise as you want, you can continue to push it up or down 1 inch at a time, or you can do fractions of an inch. It doesn't really matter. You can get as close as you want to 0, 0. But for this exercise, I'd say that's close enough. Okay, so now we have a property line that shows grading to minimize cut and fill based on the finished floor elevation of the building pad. But what about paving or driveways or other site elements that need to be incorporated into design? How can we draw them to follow the contours? Also, what is the best way to formally document the design moving forward into construction documents? All right, so let's take a look at that now. Okay, so we have this sub-region command. And this is one of the ones, some of the commands, you know, they show you a quick video. This is one of them. It shows you kind of what it does. It gives you a little description. Basically, it makes a region within the same contour and breaks it out so you can give it a different material. And you can go ahead and schedule those other materials and do whatever you need to do, okay? And it could be any shape you want. You know, this is sketch view. Just like any sketch view, you can draw any shape you want. For this, I'm just going to do a straight driveway, keep it nice and simple. Okay, I'm just going to do a rectangle. Close that up like so. And finish. Okay, so now we have our topography, we have our driveway. And as mentioned, the reason to do this is so you can give it another material. So for this, let's do that, okay? Let's search paving, which produced no materials. I could go find one, but I think I'll just switch and I'll type in concrete. And let's go with the lightweight concrete for the driveway. That's fine. Okay, let's do the same thing for the non-paved portions. Okay, so I'll type in grass, which did not produce anything. Again, I could go find the grass, but for this, I'll just say earth, which produces this one. That'll be good. Okay, so now if I go to a shaded view, you can see what that does. The driveway is still following the contours. It just has a different material. All right, so now what about documentation? So to do that first, I am going to go ahead and rename this to site plan. And I'm going to copy the view completely to, and we'll call this one the grading plan. Okay, so here's the only difference is the phase filter. Okay, so in the site plan, you can see we have show complete, which as you know, hides the existing elements, including topography. So this looks like a completed site plan. Now in grading plan, the only difference is I'm just going to switch that phase filter to show all, which will in fact show the existing topography as well as the new one. Okay, just going to make sure that the transparency is set to 100%, which it is. And then I'm going to come back and I'm just going to hide the pad. Okay, and just like that, you have a basic grading plan. You're showing the existing, you're showing the new, you're showing the revised, any revised contours are dashed. And just like that, you know, as you continue to develop your site and all these continue to move, this grading plan will continue to update itself as well, just like everything else in Revit. Okay, now what about labeling them? There is a label contours, which is this right here, and it's real easy. You just draw a line over all the contours. And just like that, it labels them exactly what they are. If and when these contours move, it will obviously adjust with it, just like any Revit tag. Same thing, just draw a quick line over all the contours you want to label. And just like that, it labels all of them. Okay, I'm going to grab these two elements and I am going to copy to clipboard, hop over to the grading and paste align to current view. And now we have both the grading and the site plan have all the contours indicated on them. Okay, so this concludes the webinar Grading for Architects. Okay, I see something in the Q&A. It says, we use floors as driveways, sidewalks, etc. How do you place a floor to follow the grade? Okay, that's a great question. And to my knowledge, I don't think you can. And that is that's the benefit of sub-region, is because you can, it will follow the grade, but if you're using floors, I'm sorry that actually, I don't think it's possible to do that. Okay, what is the best way to import a civil 3D plan into Revit? So as I mentioned kind of at the beginning, what I've done in the past, if it's not a sloped site, I've always done 2D CAD lines. Now, if you do want to go ahead and go this route of creating three-dimensional topography, I would always do linked, because when you import, well, everybody knows never ever import and explode, because you're bringing in a ton of extraneous information into your drawings. And when we're talking about civil drawings, they use millions and millions of layers, as we all know, which is beneficial to them, but not so much to architects. So I would always say link, and then after you get your topography following that link, you can always unload it. And then when they send updates, simply reload that link, unhide it, or reload it, I should say, and then you can update your topography accordingly. Okay, what's a good workflow for updating Topo Surface from civil consultants after they've built the initial Topo Surface from their first civil 3D file? Okay, again, I would say go ahead and link the file, and then draw it and then unload it after you have it, and then you can always turn it back on, and then you're kind of, let's see, there's not a good way to really click a button and automatically update. It would be a little bit of manual time, but you can basically turn those on and then use the method we showed today, which is picking points, and then just pick the points of the contours that have been revised, and then go back and unload the civil 3D file. Okay, good questions. I hope I was helpful in most of them. Again, thank you for your time. I hope this is helpful to you. Please reach out to us if you have any questions on anything related to Autodesk at all. Thanks, and I hope all of you have a great day.